Okay, the next topic I want to now turn to is that of thinking models, quote unquote. So we saw in the previous video that there are multiple stages of training. Pre-training goes to supervised fine-tuning, goes to reinforcement learning. And reinforcement learning is where the model gets to practice on a large collection of problems that resemble the practice problems in the textbook. And it gets to practice on a lot of math and code problems. And in the process of reinforcement learning, the model discovers thinking strategies that lead to good outcomes. And these thinking strategies, when you look at them, they very much resemble kind of the inner monologue you have when you go through problem solving. So the model will try out different ideas, it will backtrack, it will revisit assumptions, and it will do things like that. Now, a lot of these strategies are very difficult to hard code as a human labeler because it's not clear what the thinking process should be. It's only in the reinforcement learning that the model can try out lots of stuff and it can find the thinking process that works for it with its knowledge and its capabilities. So this is the third stage of training these models. This stage is relatively recent, so only a year or two ago, and all of the different LLM labs have been experimenting with these models over the last year. And this is kind of like seen as a large breakthrough recently. And here we looked at the paper from DeepSeek that was the first to basically talk about it publicly. And they had a nice paper about incentivizing reasoning capabilities in LLMs via reinforcement learning. So that's the paper that we looked at in the previous video. So we now have to adjust our cartoon a little bit because basically what it looks like is our emoji now has this optional thinking bubble. And when you are using a thinking model, which will do additional thinking, you are using the model that has been additionally tuned with reinforcement learning. And qualitatively, what does this look like? Well, qualitatively, the model will do a lot more thinking. And what you can expect is that you will get higher accuracies, especially on problems that are, for example, math, code, and things that require a lot of thinking. Things that are very simple, like might not actually benefit from this, but things that are actually deep and hard might benefit a lot. And so, but basically what you're paying for it is that the models will do thinking, and that can sometimes take multiple minutes because the models will emit tons and tons of tokens over a period of many minutes, and you have to wait because the model is thinking just like a human would think. But in situations where you have very difficult problems, this might translate to a higher accuracy. So let's take a look at some examples. So here's a concrete example when I was stuck on a programming problem recently. So something called the gradient check fails, and I'm not sure why, and I copy-pasted the model, my code. So the details of the code are not important, but this is basically an optimization of a multi-layer perceptron, and details are not important. It's a bunch of code that I wrote, and there was a bug because my gradient check didn't work, and I was just asking for advice. And GPT-4o, which is the flagship, most powerful model from OpenAI, but without thinking, just kind of like went into a bunch of things that it thought were issues or that I should double check, but actually didn't really solve the problem. Like all of the things that it gave me here are not the core issue of the problem. So the model didn't really solve the issue. And it tells me about how to debug it and so on. But then what I did was here in the dropdown, I turned to one of the thinking models. Now, for OpenAI, all of these models that start with O are thinking models. O1, O3 Mini, O3 Mini High, and O1 Pro Mode are all thinking models. And they're not very good at naming their models, but that is the case. And so here they will say something like uses advanced reasoning or good at code and logics and stuff like that. But these are basically all tuned with reinforcement learning. And because I am paying for $200 per month, I have access to O1 Pro Mode, which is best at reasoning. But you might want to try some of the other ones if depending on your pricing tier. And when I gave the same model, the same prompt to O1 Pro, which is the best at reasoning model, and you have to pay $200 per month for this one, then the exact same prompt, it went off and it thought for 1 minute. And it went through a sequence of thoughts, and OpenAI doesn't fully show you the exact thoughts. They just kind of give you little summaries of the thoughts. But it thought about the code for a while, and then it actually came back with the correct solution. It noticed that the parameters are mismatched in how I pack and unpack them, and etc. So this actually solved my problem. And I tried out giving the exact same prompt to a bunch of other LLMs. So for example, Claude, I gave Claude the same problem, and it actually noticed the correct issue and solved it. And it did that even with Sonnet, which is not a thinking model. So Claude 3.5 Sonnet, to my knowledge, is not a thinking model. And to my knowledge, Anthropic, as of today, doesn't have a thinking model deployed, but this might change by the time you watch this video. But even without thinking, this model actually solved the issue. When I went to Gemini, I asked it, and it also solved the issue, even though I also could have tried the thinking model, but it wasn't necessary. I also gave it to Grok, Grok 3 in this case, and Grok 3 also solved the problem after a bunch of stuff. So it also solved the issue. And then finally, I went to perplexity.ai. And the reason I like Perplexity is because when you go to the model dropdown, one of the models that they host is this DeepSeek R1. So this has the reasoning with the DeepSeek R1 model, which is the model that we saw over here. This is the paper. So Perplexity just hosts it and makes it very easy to use. So I copy pasted it there and I ran it, and I think they really render it terribly. But down here you can see the raw thoughts of the model, even though you have to expand them. But you see, like, okay, the user is having trouble with the gradient check, and then it tries out a bunch of stuff, and then it says, but wait, when they accumulate the gradients, they're doing the thing incorrectly. Let's check the order. The parameters are packed as this, and then it notices the issue. And then it kind of like says, that's a critical mistake. And so it kind of like thinks through it, and you have to wait a few minutes, and then also comes up with the correct answer. So basically, long story short, what do I want to show you? There exists a class of models that we call thinking models. All the different providers may or may not have a thinking model. These models are most effective for difficult problems in math and code and things like that. And in those kinds of cases, they can push up the accuracy of your performance. In many cases, like if you're asking for travel advice or something like that, you're not going to benefit out of a thinking model. There's no need to wait for 1 minute for it to think about some destinations that you might want to go to. So for myself, I usually try out the non-thinking models because their responses are really fast. But when I suspect the response is not as good as it could have been, and I want to give the opportunity to the model to think a bit longer about it, I will change it to a thinking model, depending on whichever one you have available to you. Now, when you go to Grok, for example, when I start a new conversation with Grok, when you put the question here, like, hello, you should put something important here, you see here, think. So let the model take its time. So turn on think, and then click go. And when you click think, Grok under the hood switches to the thinking model. And all the different LLM providers will kind of like have some kind of a selector for whether or not you want the model to think, or whether it's okay to just like go with the previous kind of generation of the models. Okay, now the next section I want to continue to is to tool use. So far, we've only talked to the language model through text. And this language model is, again, this zip file in a folder. It's inert, it's closed off, it's got no tools. It's just a neural network that can emit tokens. So what we want to do now, though, is we want to go beyond that, and we want to give the model the ability to use a bunch of tools. And one of the most useful tools is an internet search. And so let's take a look at how we can make models use internet search. So for example, again, using concrete examples from my own life, a few days ago, I was watching White Lotus season 3, and I watched the first episode, and I love this TV show, by the way. And I was curious when the episode 2 was coming out. And so in the old world, you would imagine you go to Google or something like that, you put in like new episodes of White Lotus season 3, and then you start clicking on these links, and maybe you open a few of them or something like that, right? And you start like searching through it and trying to figure it out. And sometimes you luck out and you get a schedule. But many times you might get really crazy ads. There's a bunch of random stuff going on, and it's just kind of like an unpleasant experience, right? So wouldn't it be great if a model could do this kind of a search for you, visit all the web pages, and then take all those web pages, take all their content and stuff it into the context window, and then basically give you the response. And that's what we're going to do now. Basically, we have a mechanism or a way. We introduce a mechanism for the model to emit a special token that is some kind of a search the internet token. And when the model emits the search the internet token, the ChatGPT application, or whatever LLM application it is you're using, will stop sampling from the model, and it will take the query that the model gave. It goes off, it does a search, it visits web pages, it takes all of their text, and it puts everything into the context window. So now you have this internet search tool that itself can also contribute tokens into our context window. And in this case, it would be like lots of internet web pages. And maybe there's 10 of them, and maybe it just puts it all together. And this could be thousands of tokens coming from these web pages, just as we were looking at them ourselves. And then after it has inserted all those web pages into the context window, it will reference back to your question as to, hey, when is this season getting released? And it will be able to reference that text and give you the correct answer. And notice that this is a really good example of why we would need internet search. Without the internet search, this model has no chance to actually give us the correct answer because, like I mentioned, this model was trained a few months ago. The schedule probably was not known back then. And so when White Lotus Season 3 is coming out, is not part of the real knowledge of the model. And it's not in the zip file, most likely, because this is something that was presumably decided on in the last few weeks. And so the model has to basically go off and do internet search to learn this knowledge. And it learns it from the web pages, just like you and I would without it. And then it can answer the question once that information is in the context window. And remember again that the context window is this working memory. So once we load the articles, once all of these articles, think of their text as being copy-pasted into the context window, now they're in a working memory and the model can actually answer those questions because it's in the context window. So basically, long story short, don't do this manually, but use tools like Perplexity as an example. So Perplexity.ai had a really nice sort of LLM that was doing internet search. And I think it was like the first app that really convincingly did this. More recently, ChatGPT also introduced a search button. It says search the web. So we're going to take a look at that in a second. For now, when are new episodes of White Lotus Season 3 getting released? You can just ask. And instead of having to do the work manually, we just hit enter. And the model will visit these web pages, it will create all the queries, and then it will give you the answer. So it just kind of like did a ton of the work for you. And then you can, usually there will be citations, so you can actually visit those web pages yourself, and you can make sure that these are not hallucinations from the model, and you can actually like double check that this is actually correct. Because it's not in principle guaranteed, it's just, something that may or may not work. If we take this, we can also go to, for example, ChatGPT, say the same thing. But now, when we put this question in, without actually selecting search, I'm not actually 100% sure what the model will do. In some cases, the model will actually like know that this is recent knowledge and that it probably doesn't know, and it will create a search. In some cases, we have to declare that we want to do the search. In my own personal use, I would know that the model doesn't know, and so I would just select search. But let's see first, let's see if what happens. Okay, searching the web, and then it prints stuff, and then it cites. So the model actually detected itself that it needs to search the web because it understands that this is some kind of a recent information, etc. So this was correct. Alternatively, if I create a new conversation, I could have also selected search because I know I need to search. Enter. And then it does the same thing, searching the web, and that's the result. So basically, when you're using these LLM, look for this. For example, Grok. Excuse me. Let's try Grok. Without selecting search. Okay, so the model does some search, just knowing that it needs to search, and gives you the answer. So basically, let's see what Claude does. You see, so Claude doesn't actually have the search tool available. So it will say, as of my last update in April 2024, this last update is when the model went through pre-training. And so Claude is just saying, as of my last update, the knowledge cutoff of April 2024, it was announced, but it doesn't know. So Claude doesn't have the internet search integrated as an option and will not give you the answer. I expect that this is something that Anthropic might be working on. Let's try Gemini and let's see what it says. Unfortunately, no official release date for White Lotus Season 3 yet. So Gemini 2.0 Pro Experimental does not have access to internet search and doesn't know. We could try some of the other ones like 2.0 Flash. Let me try that. Okay, so this model seems to know, but it doesn't give citations. Oh, wait, okay, there we go. Sources and related content. So you see how 2.0 Flash actually has the internet search tool, but I'm guessing that the 2.0 Pro, which is the most powerful model that they have, this one actually does not have access. And in here, it actually tells us 2.0 Pro Experimental lacks access to real-time info and some Gemini features. So this model is not fully wired with internet search. So long story short, we can get models to perform Google searches for us, visit the web pages, pull in the information to the context window, and answer questions. And this is a very, very cool feature. But different models, possibly different apps, have different amount of integration of this capability. And so you have to be kind of on the lookout for that. And sometimes the model will automatically detect that they need to do search. And sometimes you're better off telling the model that you want it to do the search. So when I'm doing GPT-4o and I know that this requires a search, you probably want to tick that box. So that's search tools. I wanted to show you a few more examples of how I use the search tool in my own work. So what are the kinds of queries that I use? And this is fairly easy for me to do because usually for these kinds of cases, I go to Perplexity just out of habit, even though ChatGPT today can do this kind of stuff as well, as do probably many other services as well. But I happen to use Perplexity for these kinds of search queries. So whenever I expect that the answer can be achieved by doing basically something like Google search and visiting a few of the top links, and the answer is somewhere in those top links, whenever that is the case, I expect to use the search tool. And I come to Perplexity. So here are some examples. Is the market open today? This was on President's Day. I wasn't 100% sure. So Perplexity understands what it's today. It will do the search and it will figure out that on President's Day, this was closed. Where's White Lotus Season 3 filmed? Again, this is something that I wasn't sure that a model would know in its knowledge. This is something niche. So maybe there's not that many mentions of it on the internet. And also this is more recent, so I don't expect a model to know by default. So this was a good fit for the search tool. Does Vercel offer PostgreSQL database? So this was a good example of this because this kind of stuff changes over time. And the offerings of Vercel, which is a company, may change over time. And I want the latest. And whenever something is latest or something changes, I prefer to use the search tool, so I come to Perplexity. What is the Apple launch tomorrow, and what are some of the rumors? So again, this is something recent. Where is the Singles Inferno Season 4 cast? Must know. So this is, again, a good example because this is very fresh information. Why is the Palantir stock going up? What is driving the enthusiasm? When is Civilization 7 coming out exactly? This is an example also, like, has Brian Johnson talked about the toothpaste he uses? And I was curious basically like what Brian does. And again, it has the two features. Number one, it's a little bit esoteric. So I'm not 100% sure if this is at scale on the internet and would be part of like knowledge of a model. And number two, this might change over time. So I want to know what toothpaste he uses most recently. And so this is a good fit, again, for a search tool. Is it safe to travel to Vietnam? This can potentially change over time. And then I saw a bunch of stuff on Twitter about a USAID, and I wanted to know kind of like what's the deal. So I searched about that, and then you can kind of like dive in a bunch of ways here. But this use case here is kind of along the lines of, I see something trending, and I'm kind of curious what's happening, like what is the gist of it? And so I very often just quickly bring up a search of like what's happening, and then get a model to kind of just give me a gist of roughly what happened. Because a lot of the individual tweets or posts might not have the full context just by itself. So these are examples of how I use a search tool.